My name's Adam. I'm an enterprise architect, and today I'm going to be talking about the EU Artificial Intelligence Act. You're probably wondering what an enterprise architect is doing talking about regulation. That's because I'm fascinated by it. I love regulation. I love reading it. I love thinking about it. I love even contributing to it. But as a consequence, I don't get invited to many parties. And they absolutely don't let me out of the office very often. So thank you for coming and listening to this. With all said and done, this is actually quite a dry subject. So I'm going to try and breathe a bit of life into it and have a bit of fun with it, because regulation can be long, and some people say boring, not me. So I'm going to try and breathe a bit of fun and life into this. I've got a little agenda I'm going to follow. We're going to talk about regulation in a context, because this is not just one singular act. It is surrounded by other really interesting regulation. Then we're going to talk a little bit about what it is, why it's here, how we're going to use it, and then we'll look at some tools in the technical sense of how we can meet the requirements of it. And then we'll wrap up. So a quick nod to regulation in itself. Now this is the bit that I think is interesting. What generally happens here is we develop new technology, and it takes us 5 years to regulate it. So if you look at social media, it powered ahead, and yes, it had great positive impacts, but it also had quite negative impacts. And legislators, lawmakers, raced to write stuff, but they're on the back foot. So people have taken that, and they're going to do better. And the EU is getting a lot faster and a lot better at writing regulation. So there is a number of regulation pieces coming, and we can break them down into generally 4 different brackets. You've got data and AI. That's what we'll be talking about today. We've got the EU Artificial Intelligence Act. You'll also see the UAE Reg Lab. That's places like Dubai, where they are at breakneck speed developing artificial intelligence. On one hand, they're doing that. On the other hand, they're writing the regulation at the same time. They're doing them at the same time. It's a lot faster process. And then we have privacy and security. And the reason I mention this is because they all are slightly aware of each other. So the EU Act is aware, ever so slightly, of DORA, and NIS2. DORA was mentioned earlier today. If you don't know what that is, that's the Operational Resiliency Act for financial sectors. So if you're a finance company, bank, insurance company, anything like that, you have to abide by that. And if you're developing an AI, you have to abide by that, and they both know each other. And then we have the digital economy. This is one of the even fascinating areas. We have things like the EU Chips Act, which is going to be amazing. It's going to enable billions of euros within the European Union while we build our own chips. We secure our own pipelines. We all saw what happened during the pandemic. We had car manufacturers stripping washing machines for chips to build cars. So we've learned our lessons, and we're going to make our own chip fabs. Then we have the catch-all bracket. We won't dwell on that. So that gives you a context of why regulation and what's coming. But AI specifically is phenomenal. Each individual country is trying to regulate this. Everyone's doing something. You've got India with the Digital Act. You've got the EU, one we're talking about today. The Americas have the executive order. That's like there where the president writes something, signs it, and says, make it so. And then we have even people like the AI bill in Brazil. And what we're seeing here is people are coming in with 2 different schools of thought. They're thinking, regulate the technology. That's hard, because as soon as we regulate something, someone innovates past it. How can we define where we are when AI is moving so quickly? And then you have people regulating its use. That's a well-trodden path, regulating the use of something. That's what the EU AI bill does. It kind of spans a little bit of both, but it's more in its use. Now, the reason these are being published with such speed, in my personal opinion, is because there is big change coming. Legislators write things when there's a power shift coming, or they're learning from mistakes, or someone's going to get hurt. I'll say that again, someone's going to get hurt. If we use this thing in our critical infrastructure, we need to be careful of it. Regulation, good regulation, walks a really fine path of protecting us, allowing a free market, but at the same time fostering innovation. And they say sometimes regulation is written in blood. And that is because if you look to the back of the room, there's a little plaque telling you how to escape this room. And there's a fire exit sign illuminated. Those things were put there because we wrote regulation, because someone got hurt. So good regulation stops us from getting hurt before it even happens, but fosters innovation and gives us all guidelines to play with. So moving on, what is the EU Act? I'm going to summarize it in one sentence, and then we're done. You can all go home. Right. It is to create a safe, transparent, traceable, non-discriminatory, and environmentally friendly. They shoehorned that in the end, environmentally friendly, when you've got Microsoft talking about building nuclear power plants to power its AI. This stuff is sucking resources at a phenomenal rate. So we have to look at our environmentally friendly policies. I'd say traceable and transparent are also very important. I want to know when I'm interacting with an AI. I'm sure you do too. And I want it to be traceable. If I'm going to use it in my critical infrastructure, I want to know what decisions were made and why and with what accuracy. And safe. Non-discriminatory. That's a good one because it's incredibly hard to do. Because AI is a reflection of ourselves. It's almost impossible to create something from a blank slate because we can't even imagine it. Everything we create is the image of ourselves and the worlds around us. So how do we do that? It's very difficult. First off, we're going to do some really tedious stuff. We're going to quickly have a nod to definitions. Definitions are very boring, but we absolutely need them. Because I need to know that I'm talking to you, or you, or you. We all agree on what AI actually is. And we all agree on what a deep fake is. I bet if I asked a number of you what deep fake was, we all had a different idea of what a deep fake is. So definitions are important, and we have to have them. And they are in the articles. They're in Article 3. One I'm going to nod to here is serious incident. They've specifically detailed what a serious incident is. And this harks back to what I was saying earlier. We need to be able to define what a serious incident is because we do not want one. And it is hurting somebody, material damage, or damaging critical infrastructure. So it starts off with this. The EU AI Act starts off with a general provision and a subject matter. And the subject matter is more of what I've just discussed. It sets the theme for what we're going to do. What we're going to do is we're going to harmonize rules. So everyone in the EU has the same rules to play by. And if you want to come to the EU and play in our market, you have to abide by our rules. Same as GDPR. Secondly, we're going to stop certain AIs. We're going to ban them. You can't do that. No, not allowed. Then we're going to have some requirements on high-risk AIs. And we're going to do some other things. Transparency, as I said, and market monitoring. This is important because we've all seen GDPR. It was actually very well received. It's been copied around the globe. Most countries have copied GDPR, and it's been heavily enforced and used. If someone's messing with my data using it, I can go to the Commission and say, they're using my data in an appropriate manner. Enforce it. We want the same mechanisms for this. So market monitoring is important. But do we need this? Do we need this regulation? Well, we polled people. I say we, I didn't write it. It wasn't me. It was the good people at the EU Commission. They polled, and 61% of Europeans look favorably on AI, which is quite a good metric. But 88% we say we absolutely have to carefully manage this. So this answers the question of do we need it? People say yes, we do need this. How do we approach this? So how do we take this mammoth task of regulating AI? How do we approach it? What we do is we break it down into a risk-based approach. Your AI will fall into an unacceptable category. That's banned. You can't do it. High risk generally involves safety components. We'll show examples of all of these shortly. And then you have limited risk and minimal. They're more guidelines. We won't really cover them today. We're going to zone in on the first two because these two have requirements, but they're very light touch. So high risk and unacceptable. Let's have a look at high risk. High risk. Sorry, go back. Unacceptable. Unacceptable is anything that fundamentally affects someone's behavior. So this is an example. Cognitive behavior manipulation. If I create a children's toy to manipulate a child into doing something dangerous with AI, that's banned. I'm quite upset about that because I really want a toy to teach my 4-year-old to stop shouting at me from a different room. But apparently I'm not allowed to make one. Social scoring. I know some countries have gone down this route, but we're saying no. To do social scoring properly, you need advanced AI, and we're saying you can't use AI for that. It's banned. No. And real-time biometric identification. That was in my definitions, if you recall. We're saying no to that. We can do it under extreme circumstances, such as law enforcement. And I believe this was pushed through for things like the Olympic Games, which is coming. So if there's a terrorist threat or there's a missing person, we want to be able to do real-time biometric identification. Think cameras scanning people walking down the street, looking at them going, who's that, who's that, who's that, is that my missing person? But you absolutely have to use it as an exception. You have to get, I believe, a court order or something. High risk. High risk, remember I said safety components. Anything with really a safety component, anything that fits in critical infrastructure. So a good example of this is if we used it in train switching software. Now we're already looking at optimizing train routes. We could use IA for that. What if we took the next logical step and say we're going to send a train this route or that route dynamically to optimize our infrastructure? What happens if that AI makes the wrong decision and two trains collide? We absolutely have to have some rules around this. Secondly, for education, we're already using education to write our exam answers. People are going to use it to mark our exam answers. If I spent 3 years training for an exam and someone used AI and it's only 60% efficient or 60% accurate, I'm going to be fuming if someone gives me the wrong answer or gives me the wrong mark. So we need components to judge if it's fair and if it's safe. I won't go through all the others, but you can see what they're trying to do here. Moving on, what are the requirements? So the requirements are generally around the high-risk AI, the areas we just covered. And there is a process that you need to follow. It's 4-stepped. I'm not going to go into it today. What we're actually going to do is move on to the actual technical articles and talk about some of the cooler, more intricate bits. And the enterprise architect in me is going to come out. The articles and their requirements. Now, it's really cleverly written. If you've ever read this sort of stuff, by the way, I don't encourage it. It's 400 pages long, size 12 text. If you have a problem sleeping, feel free to read it. But it's written in articles, and each article's got a nice, easy title. So it's read so we can. It's written so we can accessorize, we can read it and understand it, because the layman person needs to be able to kind of understand this stuff. And these are a couple that I picked out that are really interesting, and we'll dive a little bit into them, and we'll look at how we can actually meet these. So first off, record keeping. Now, it says, you'll see on this side here, I've written an actual quote from the article, and I've summarized it a little bit on the white side. So this says here, high-risk systems, remember, those things with safety components or in critical infrastructure, anything like that, they need to have automatic log keeping. Why do I need logs? I need logs because logs tell me a story. Logs tell me why the AI made the decision it made. I need to know how it got to where it was going. Secondary, I need to make sure it's traceable. I need to know if a human being or a natural person, they call it a natural person. I don't know why that implies there's an unnatural person, but I don't know what an unnatural person would be. A natural person identified as saying that decision is correct. So a fingerprint, someone saying, I believe the AI, I believe what it's doing, I believe what it's saying. And we need this because I already believe half the things ChatGPT sells me. If it says this is the answer to that question, I'm like, yep, it's definitely right, because inherently we are trusting human beings. We trust what information we are given, because it's so exhausting to not trust everything that we're given. So we need accountability, and we need these logs. And they need to be kept. We need to reference our input data and our databases. So what should we do with this? What we need to do with this is think about this on an infrastructure level. So let's take an AI system. If we have an AI system and it's generating these logs, we need to make them tamper-proof, because in the context of cybersecurity, attackers love logs. They want to delete those logs because they tell the story of how they got in. So we need to keep our logs tamper-proof, immutable, so they can't be deleted. And then we need to add in our human fingerprints. We could do this via API calls. We could say, Adam checked that decision that AI made. The train is safe to go down that route. And then we wrap them up in a wrapper and we ship them off. We put them in a third site. Could be another data center, could be anywhere. Just keep them protected and keep them secure and keep them immutable. Because if this is an AI in medical imaging, you need to keep certain medical data pretty much indefinitely. So it depends on what industry you're in. So that's how we can do or meet some of the requirements of the logging. Moving on to transparency provision of user information. This is cool. It talks about transparency to enable users to interpret the system's output and use it appropriately. We have a tendency in IT to create incredibly complex, difficult systems that are command line driven, and you need like a degree in physics to understand it. We're saying don't do that. Please make this so I can understand it, because I'm a bit dumb, and I need things to be presented to me in an easily understandable way. And the outputs as well. And we need to document its characteristics and its limitations. Again, I go back to that example. If I'm marking exams, I need to know the limitations of my AI for marking an exams, so I can use it in an effective manner. I also need to document the accuracy. We need to also have a look at our cybersecurity, but we'll talk more about that later. So before I talk about solutions for this, I usually say, step back. Step back and look at what you're going to do with your AI and how you're going to use it. Because the data you put into your AI is critical. It's a sausage machine. You put in rubbish, you get rubbish out. And this is a great time while you're looking at your data, categorizing it, tagging it, making sure it's clean, to also look at your security. Because you scan your environment, say it's a file environment, and I find all the permissions. And this shows all the permissions in my environment are open. That's pretty bad. I don't want everyone to be able to access all my data, so I can lock down those permissions. I can identify what's PPI data. Does that really need to go into my AI? Personal identifier information probably shouldn't, or it should at least be anonymized. So we need to look at our data before we go feeding it into the AI. Make sure it's clean, make sure it's all categorized nicely. Human oversight. This is where we need to look at high-risk systems and make sure they can be effectively overseen by a natural person, and to fully understand the capabilities and limitations. We also need here, this is cool, look for anomalies, look for dysfunctions, and unexpected performance. I need to find these things in my AI. And I also need a big red stop button to say, stop doing what you're doing, AI, turn off. Now you can see why we want one of those. I tried to pitch to our marketing team that we should put a big red button on our arrays and you could just smash it, it turns everything off, but they shot me down. They said that would be a bad idea. I still think it's a good idea. So how do we do this? How do we look at our AIs? How do we look at our environment? Because our environment tells a story, and look for these anomalies. We use user behavior analytics, which is AI-driven and ML-driven. We're using AI to answer AI questions, which is pretty cool. So what we do here is you train an AI on your environment. Adam creates these presentations. He presents to you. That's mostly what I do. I don't do much else, if I'm honest with you. If I started deleting financial records or looking at things that I shouldn't, user behavior analytics would flag that and say, he's doing something he shouldn't be doing. That's anomalous behavior. Maybe that's a dysfunction. And we can set autonomous activities. We could lock me out. We could delete me. We could snap my environment, snap it so no one can change it, or I can roll back to it or something. And then I layer on top things like encryption monitoring. Everyone's got encryption. If I sent you my paycheck, it would probably be encrypted. If you've got an Oracle database, it's a good chance it's encrypted. What we don't want to see is that, a big old spike. That's someone attacking your environment. That's a dysfunction, that's an anomaly, that's something bad happening. We also don't want to see the slow trickle either. They're even harder to detect. Usually, someone in your environment is in for months before you detect them, and they're slowly encrypting your environment while they infect other companies. So that's where we use user behavior analytics and encryption monitoring together to figure out what's going on. Moving on to the next one, accuracy and robustness. This is the bit I like the most, because it's my area, cybersecurity. I love a bit of cybersecurity, who doesn't? This is where we talk about the accuracy and robustness of cybersecurity in the solution, protecting my AI. We talk about technical redundancies to my solutions. Imagine if I built an AI to switch those train tracks, to send a train down route A rather than route B, but it fails, and I've got a train coming. What do? Do I fall back to paper and pen? Do I fall back to a spreadsheet? Do I have another AI in the wings waiting to pick up the slack? Whatever it is, you have to document it and test it. Test it on an annual basis. Make sure it works, because this is high-risk AI. It's an environment where it affects my life, it affects your life. So absolutely need backups and fail-safe plans. We also need to monitor for unauthorized third parties altering the performance or exploiting the vulnerabilities in our system. It's actually quite easy, really quite easy. And one thing they don't want is poisoning of training data sets. What they don't want is people manipulating a data set which an AI is trained on to make it do nefarious things. So what they're looking for is adversarial examples. This is quite difficult for me to define, actually, but for example, if I have an autonomous vehicle and it sees stop signs, it's been trained on stop signs and always stops on stop signs, but I had a secondary data set to it that says stop signs with mud on them mean go fast, accelerate. That would never happen. We've already dealt with that situation. Don't worry, your car's fine. I'm just giving you a made-up example. That would be an adversarial, someone messing with my model, poisoning my training data set, getting it to do something I don't want it to do. So how do we protect against these things? What we do is we look at our environment holistically. Now, you've all seen this before, so I probably won't go into it too much, but we need to protect from the top to the bottom, from the start to the end. It starts out at endpoint devices, goes into our networks, goes into our applications, and then it goes right to the crown jewels. This is the castle where they want your data. This is where we roll out the big guns to protect our stuff. Because attackers, this is what they want, this is what they're after. And we use things like encryption blocking, MAV, multi-administration verification. We use honeypotting, and there's a great article on this published by my good friend Chris. This is where we create a folder in your environment, and we call it something cool like super secret IP. Please don't read. And then we monitor it with our user behavior analytics, and as soon as someone walks into it, sets off alarm bells. 9 times out of 10, you catch me, because I'm nosy, and I'm looking at things I shouldn't be looking at. But 1 time out of 10, you catch your attacker, and then you can lock down and fix the issue. So underneath that, we pin it all with these 4 pillars. I'd point to education as being the most important here, because the weakest link has always been and will always be human beings. We are the weak link. Technology works. It does what we train it to do. Generally, we're the weak links. So education and logging. Multi-admin verification. That's a fun one. I'm just going to take a quick brief talk about this. This has actually been used in many technologies. If you think of it as the nuclear launch keys, you know when you watch those movies in Hollywood and they're like, launch the missiles, and it's 2 people, they put the keys in at the same time, missiles go up. It takes 2 people to do that. Why? Because if 1 person goes rogue, they can't launch it. It takes 2 people. It cuts down the chances of something going wrong. And we use this in our environments. We should be using it for big training set runs. We should be using it for creating copies of our environment, deleting things that are, don't want to be deleted. It takes 2 admins to do it. And again, 9 times out of 10, you just catch someone like me who used to be an admin and deleted things by accident all the time. And so another admin, it just stops me from doing that. 1 time out of 10, you catch someone trying to do something they shouldn't be doing. So MAV is important. My wife works in finance. Whenever they do a pay run, they always use something like MAV, because it takes 2 financial controllers, to make a pay run. End-to-end encryption. Now, why am I talking about encryption? So boring, so boring. You would be surprised how many tier 1 financials and big organizations I approach who aren't encrypting their data. That's my data, that's your data. It's sat on an array. Your phone's encrypted. These arrays should be encrypted, and it's so easy to do. So these are some things we should be doing. And malicious file blocking. This is fun. We pretty much know 3,000 extensions that they want to create in your environment. 3,000 nefarious bad extensions. We can block them all. Or we can reverse it and whitelist it, so you can only create a .txt file or a .word file in this environment. This stops people creating things they shouldn't be creating. So, won't this slow regulation? I'm going to take a quick breather, because I went pretty 100 miles an hour. Won't this slow regulation? And I always get asked this question. Generally, it's the Americans that ask me. My American counterparts, they always say, hey, Adam, the EU regulates. US of A, we innovate. That was a really bad impression, but I've been practicing that for a while, so I was going to use it for a bet, and I've done it. Okay. Well, the EU have thought about this, because I largely agree with Americans on this, their sentiment. Good regulation allows innovation at the same time as giving these guardrails, and it fosters innovation if you do it right. And the EU are saying, if you abide by our rules, you get access to our market, and our market is huge. And also, there's been studies proving that if a market is secure, if I know I'm trading with you, and I know who you are, and you promise me, I can prove it, and I know the goods and services I'm giving to you are valid in exchange, market grows. The more security you add to a market, the more people will come to it. So this is why we need good regulation twinned with innovative ideas. And we'll also give access to innovation hubs for small startups. And what is really cool, sandboxes. Because meeting regulation can be hard. Technically, it can be hard. I've got to do a lot of things. I've got to report to a lot of people. And by the way, I've only covered 4 articles. There's like 50. There's loads of them to read. They're going to set up sandboxes where you can put your AI and you can make sure it meets the regulatory standards. There's a call to do that. If anyone wants to set up a business doing that with me, give me a shout. I would love to do it. If you don't do these things, there are fines. And a lot of people seem to think, oh, I won't get fined. You should go on the Google and type in GDPR fines and look at the long list of fines that were imposed. Huge fines. Do not mess around fines. And they do it like this. They do it as a percentage of your worldwide turnover. And they do that cleverly because then it's not a speed bump. It's not a speeding fine. Big organizations get used to paying fines. They're like, I'm going to develop this AI and I've got to pay $1 million. I'll pay $1 million. When it's a percentage of your annual world turnover, CEOs start to listen. And there's two different brackets there. One's for, I think, the restricted AIs, and one for the high-risk AIs. What about generative AI? It's already out there. That would fall into the minimum risk sort of areas, so where it's light touch. Now, there are some things. No fakeness. Someone once told me I look like Simon Garfunkel. I have no idea who that is, so if anyone knows who that is, please tell me, enlighten me. But you can clearly see that's fake. I have to label stuff that it's fake if it's fake. And I can't have my AI generating dodgy content. No generating illegal content. Seems like logical stuff. Probably shouldn't do it. And we need to publish summaries of our copyright data we've used for training our models. That all seems like fair. I want that. That seems fair. When will the act be applicable? Well, I believe it's already in force, but it actually comes out in rolling phases. So banned AIs is 6 months after ratification. So once everyone's agreed and we've passed it into law, 6 months later, those banned and prohibited AIs are definitely banned, and we can come and get you if you put them in service. Then it's a phased rollout, bit by bit. And this is to stop market shock. It's to allow people to get used to it. It's a very good approach, I would say. But that was a lot of information, and I'm really grateful for you all sitting so far and not falling asleep. Like, I can see no one asleep, which is really impressive. Thank you. Let's put it all together in an environment and see what we can do with it. So we'll start with our AI again. We'll take our logs, we'll make them immutable and tamper-proof so no one can delete them, because we need those, because they tell that story I was talking about. Whether it be cybersecurity or decision-making, absolutely need those logs. And then we're going to create immutable copies, a logical air gap. A logical air gap is where we have this AI in our storage and all our bits and pieces, and we take a copy of the data, we put it over here, and we say cannot be deleted, and it's a separate system, but it actually sits on the original system, but we've used software to logically make it different. We make it logically air-gapped, and we should do this with some of our training data. For example, if we're training medical images, and they are doing this now for cancer patients and stuff, because it's phenomenal, what we can do is we can create training material for, generate material for students to learn from, because there isn't enough. So generating it is a really easy way of giving training material to people. We should, if the training data we did it on, we should create a logical air-gap copy of it to prove what we used to get to where we got. And then a subsection of it, we ship off to a third-party site. That I call your MVB, minimal viable business. We ship it off to a third site. We put a little bit of compute. We put a little bit of networking. You also put your logs over there and all those bits and pieces. And this is your forensic examination area. It's your cyber vault or something like that. There's many different terms for it. If there's an issue with my AI, if there's an issue with cybersecurity, this is where I go, because it's all there. It's all been scanned as it goes in for threats, or gets scanned as you start examining it. And I pick through it with my lab coat on, and I look for the issue, and identify the issue, and then I fix the issue. In a wider environment, this isn't critical, because what you have is people restoring from this area back into that area and reinfecting themselves, or not plugging the gap of how the criminals got in. On top of that, I start layering in all my cool, well-known technologies. Reporting is key. That's why I've written it in red, because there's a lot of reporting in the Act. You have to report in on certain things. Haven't covered that today because it's very laborious. We rely on user behavior analytics, which I've discussed, ransomware protection, all the way down to file policies. And then the last one, API calls. Where possible, this should all be driven by APIs. So that's me showing the environment, the whole thing. Thank you very much for sitting and listening to that. If you would like, please add me on LinkedIn. I don't have many friends because I talk about regulation too much. And if you want to come and talk to me afterwards, if you've got any questions, I would love to answer them. I am not an expert. I'm just someone who loves this stuff. But hopefully that was enjoyable. Hopefully I made it a little bit more exciting than reading the actual Act itself. Thank you all.